All right, we are going to talk about molar mass and density of a gas. All right, remember that molar mass is abbreviated with two capital M's. Molar mass is mass divided by moles. That's all. Molar mass, that's grams per mole. That's the mass of the gas. Measured in grams. And then that is, of course, moles. Measured in units of moles. And then the density of a gas, or the density of anything, is mass over volume. Well, when we talk about gases, mass is still in grams, but gases take up a large volume, so we give their volume in liters, okay? And that gives us a density in grams per liter. And if all gases, just remember molar mass of a gas, molar volume at STP, and that's any gas, is 22.4 liters. So 1 mole of any gas will take up 22.4 liters. So what determines the density of a gas at a given volume? It's molar mass. The larger the molecule, the denser the gas. The smaller the molecule, the less dense the gas, okay? Because the only thing that changes is that density. Is that molar mass, and that's what affects the density. So if you look in your textbook, there's an equation for molar mass of a gas, and there's an equation for density of a gas. Those are not given on the ACS exam, so I'm not going to give them to you now. What I am going to do is show you a completely different way to solve these problems without using equations, okay? Except for PV equals nRT, which you guys all have memorized anyway. So let's just do density first. What is the density of O2, and that's O2 gas, at 20 degrees Celsius and 1 atm. All right. So we're looking for density. And remember that density is equal to mass over volume. So we need to find a mass and we need to find a volume. All right. So one thing we know is that we have O2. So O2, the molar mass is 32.00 grams per mole. So we can say that 1 mole of O2 is equal to 32.00 grams of O2. So look, there's our mass for D equals M over V. Now we have to ask ourselves a question. What is the volume of 1 mole of O2 at 20 degrees C and 1 atmosphere? Don't tell me 22.4 because this is not STP. That's only for STP. So all we have to do is use PV equals nRT and solve for volume. So volume is equal to nRT over P. And N, we're just doing 1 mole. So it's 1 mole. R, 0.08206 liters. That will be given. Liters times atmospheres divided by Kelvin times moles times temperature, 293 Kelvin. Remember, you got to use Kelvin. All over 1 atm. And that works out to 24.0 liters. Now, ask yourself, does that make sense? 24.0 liters. we're at a higher temperature than STP. Same pressure as STP, 1 atmosphere, but a higher temperature. So should our volume be larger or smaller than at 0 degrees Celsius? Well, it should be a little bit bigger. The molecules of O2 are moving faster. They collide with the walls of the vessel with more force. Therefore, they exert more pressure. Therefore, we're slightly above 22.4 and we have 24.0 liters. Okay. Now we have our mass and our volume. All we have to do is plug them in. D is equal to M over V, our mass. And remember, we know the mass of 1 mole from the molar mass is 32.00 grams. The volume of 1 mole we just calculated as 24.0 liters. And that gives us 1.33 grams per liter. No special equations needed. Okay, that is way easier than trying to memorize a stinking equation. Just figure out the volume and the mass of a mole. All right, next problem, same idea. What is the ID, the identification, or the identity of a gas whose density at 125 degrees Celsius and 755 millimeters of mercury is 0.852 grams per liter. All right, we're looking for the identity of a gas. Well, what the heck does that mean? Well, we got to figure out what gas it is. To figure out what gas it is, the easiest way to go about that, given the information we have, is to find the molar mass. Molar mass is mass over moles. Oops, mass over moles. So we need to find a mass and a moles, number of moles. So what do we know? We know the density is 0.852 grams per liter. So we know that 1 liter of gas is equal to 0.852 grams. Oh, there's our mass. That's a weird arrow. Okay. Now what do we need to do? Well, we need to find the, not the volume, because we have the volume. We need to find the moles of 1 liter. So what are the moles of 1 liter of gas at 125 degrees Celsius and 755 millimeters of mercury? Okay. PV equals nRT. I hope by the end of this chapter you are sick of seeing that equation written. All right, that will mean you have it memorized. So we're looking for moles. N is equal to PV over RT. Just plug and chug at this point. All right, 755 millimeters of mercury. Volume, 1 liter. That's from right here. All over. Uh-oh. We have millimeters of mercury, and R is 0.08206 liters times atmospheres by Kelvin times mole. Can't use it because of the atmospheres and the millimeters of mercury. 2 ways you can go about fixing that problem. You can convert 755 millimeters of mercury into atmospheres. How do you do that? 755 millimeters of mercury times 1 atm over 760 millimeters of mercury. You just plug that in, or you just solve, excuse me, and then you can plug that in for your pressure and then use this value of R. Or we can use a different value of R. That's what I'm going to do. Just to show you can, you just look this up, 62.4 liters times millimeters of mercury divided by Kelvin times moles. So notice, I just have to be cautious that my units all match or they all match R. Millimeters of mercury cancels out, liters cancels, Kelvin cancels, and we're left with 1 over moles on the denominator, so that gives us moles in the numerator. We come out with 0.0304 moles. And recall from above, molar mass is mass over moles. Our mass was the 0.852 from above, 0.852 grams, all over 0.0304 moles. And that works out to be 28.02 grams per mole. Now we consult the periodic table and we'll find that silicon has a molar mass of 28.0 grams per mole. Is this silicon gas? It's not silicon gas, okay? There's another gas that has a molar, or there's another element that has a molar mass of 28.0 grams per mole. Anybody know what it is? N2, okay? Silicon is not going to be a gas at 125 degrees Celsius. You know, that's not something you necessarily know off the top of your heads, but N2 is definitely a gas at room temperature and a gas above room temperature. It's what composes most of the atmosphere. All right, that's it for this video.